So next, let's talk about the application problem for sine and cosine law. So we're going to discuss about the application in terms of bearing. So what happened is that in terms of the direction, I'm not sure, you probably know, you probably don't know about this, but this is going to be the direction, the bearing. So what happened is that at the top over here, this is going to be north, anything that goes right in front upwards. So that is going to be called as being the north direction. So underneath, opposite to the north direction, it's going to be the south direction. So on the right hand side, that is going to be east. And on the left hand side, that is going to be west. So whenever I got confused between east and west, I always sort of like visualize the map, the world map, the fact that Malaysian is going to be on the right hand side and all the European countries will be on the left hand side. They're the western countries and we are the eastern countries. So that's how I visualize, so which direction is west and also east. Okay, how do you read bearings? Okay, for example, so P right here, so it's going to be the bearing of P from O. So this is going to be our origin. So moving from O to P, so it's going to be north 40 degree. It's because we started at north, we started over here. So we move 40 degree and we move at P. So the direction is going towards north to east. So that is why it's going to be known as north 40 degree east. That's the reason. And if I were to pick another one, for example, it's going to be Q. So the bearing of Q from O. So this is O, where we start. This is our O. And we're going to move to Q. And upon moving to Q, it's going to be a 55 degree direction. And we go from south towards east. So therefore, it's going to be south 45 degree towards east. So it's going to be south 55 degree east. So that's how we tell. So this is where you start and this is where your direction is heading towards. So you start from south and you're heading towards east. So that is how you read the bearing direction. Okay, and using the bearing, so we're going to start with, I'm going to show you this application problem over here. I know that this is not going to be easy for you to visualize, but you have, when you come across a question like this, so you have to read them again and again until you can actually visualize what's going on in your head. Okay, so here it says that a small fire is sighted. So we have a fire sighted from ranger stations A and B. So we basically have two stations A and B, and a fire can be seen from both stations. And the bearing of the fire from station is north 35 degree east. So this is the first information that we have, that a fire from station A is north 35 degree east. Let me prove here. This is our first information. And that the bearing of the fire from station B is north 49 degree west. So that is going to be our second information. And station A is 1.3 miles due west of station B. So this is going to be our third information. So basically, so here we have three places that we have to spot the direction. First is going to be station A, and then we have station B, and then we have the fire. So those are going to be 3 points that we have to allocate in our sort of like in our sketching. So I have copied it over here. So first, as I mentioned to you before, fire, this is our first information. So this is going to be our second information, and this is going to be our third information. And from these three informations, I'm going to sort of like sketch and figure out, so where is the direction going to be. So I'm going to have a bearing over here that I can refer to. So this is the north, south, east, and west. Okay, first of all, I'm going to use the simplest information. And I figure out that this simplest information is going to be over here. So the fact that station A is 1.3 miles due west of station B. So A is going to be on the west of station B. So on the west is going meaning that if we start from here, so it's going to point towards the left. So therefore, if this is my station B, okay, this is my station B. So if I go somewhere towards the left, which is heading west, for how many miles? For 1.3 miles. So this is going to be the second station, which is station A. So that is the information that we have over here. Okay, that is the first information. Using the second information, so let me pick the first one. It says that bearing of the fire from station A is north 35 degree east. How is north 35 degree is? Okay, so meaning that if I start over here, north, so if I have 35 degree towards the east, so this is going to be the direction for A. So therefore, so if I were to sketch that this is going to be our north 35 degree is going to be somewhere over here. So here, and this is going to be 35 degree. So therefore, if I were to extend over here, so this is going to be our fire. So that is information that we have from our direction. And it says that the last information is that it says the fire from station B, so it's this one from station B, so the fire is north 49 degree west. Where is north 49 degree west? So this is our north, and moving towards the west, so it's going to be on the left. So therefore, if I were to make a straight line over here, so this is going to be my straight line, so it's going to be 35 degree. So I'm going to assume, no, it's not going to be 35, it's going to be 49. So it's going to be a little bit more from what we have previously. So this is going to be about 49 degrees. So I'm going to assume that. So this is how the location actually looks like. So it's going to be in terms of a triangle. So I'm going to have, this is my stations A and B, and this is the location of the fire. Okay, so now that I already have all this information, so I'm going to start answering the question. So the question asks you, how far is the fire from each ranger station? So basically, we need to find the length. So we're going to find the length over here, so which is AF. And we also need to find the length over here, which is going to be BF. Okay, from the information that we had, so first of all, so we don't have any angle at all in the triangle. So let's see if we can find any of the angle. So actually, yes, because if you notice, this is actually a 90 degree angle. So because of that here, we can tell right away that 90 minus 35 degrees. So that is going to give us a value of 55 degree right here. And the same goes for the angle at station B. So this is going to be also a right triangle. Okay, so 90 minus 49 degree, so that is going to give us a value of 41 degree angle. So those are going to be our angle. Okay, and now, so now that we wanted to find what is going to be the angle of this, the length on both sides of AF and BF, so we have another information that we can use. So the fact that the length from AB is going to equal 1.3. So therefore here what I can do is I can actually use the sine law because I have enough information for that. But if I wanted to use the sine law, I need to figure out what is going to be the angle opposite to the point 1.3, and we can simply do that by using the fact that the sum is going to be 180. So the angle at F is going to be 180 minus 55 degree minus 41 degree. And that is going to be 50 minus 5 minus 41. So I will get an angle of 84 degree. So that is going to be the angle at F. Okay, so basically as I mentioned to you just now, so you can either use sine law, you can either use cosine law, that is up to you. But in my defense, I would prefer to use sine law. If I have enough information, I prefer to use sine law because it's going to be easier. Okay, so now I'm going to find, let's see first, I'm going to find what is going to be AF. So AF, the length is, it's going to be AF over, so the angle that is opposite to my AF is going to be 41 degree. So I'm going to have sine 41 degree is going to equal 1.3 over, so this is going to be sine of, from our calculation, it's going to be 84 degree. And I simply have to use multiplication and division. I'm going to have 1.3, so divide by sine 84, so multiplied by sine 41, so that is going to give us a value of 0. So it's going to be 85757, but I'm just going to take two decimal places. I'm going to take 0.86, and the unit for this is going to be in terms of miles. How do I know it's going to be miles? Because so this is 1.3 miles, so I know that the distance is going to be calculated in terms of miles. Okay, so that is going to be our first distance, so which is going to be the F. And we also need to find what is going to be the distance for BF. And I'm going to use the same rule. So I'm going to have BF over, so sine of, so what is going to be the opposite of BF? So it's going to be 55 degree is going to equal, so 1.3 over sine of 84 degree. So BF is going to equal, so it's going to be the same calculation as previously. So the only difference is that now I'm going to have to multiply by 55, sine 55. So that is going to be 1.07 miles. Okay, so that is going to be our distance of BF. So we have answered the first one. So the question asks you, how far is the fire from each ranger station? So from A to the fire, it's going to be 0.86 mile. And from B to the fire is going to be 1.07 miles. So we are done with the first problem. Okay, so now let's move on to the second problem. So let me copy this. So this is going to be an extension from the previous problem. So let me sketch whatever that we have previously first. So previously we have some like this. This is roughly the sketching. So this is our station A, this is our station B, and this is the fire. And here we have an angle of 35.49. This is information that we have. And 49, so basically, so this is an information that we get from the first problem. And of course here it should be a straight line from A to B because it's just west. It's going to be a straight line from A until B. Okay, so now let's read the problem for B. So it says that at fire station B, so it turns out there's another fire station. In this case, it's going to be known as C. So it is 1.5 miles from A. So from A, the position is going to be 1.5 miles. So that is a helicopter that can be used to drop water on the fire. So we're going to turn off the fire by using the helicopter from fire station C. So it says that if the bearing of C from A is south 42 degree east, so this is north, south, east, west. So it says over here south 42 degree east, so it's going to be that way of C from A, so meaning that we start A is going to be that direction towards C. So it says if the bearing of C from A, okay, it's south 42 degree east, find the distance from C to the fire. Okay, so this is going to be our bearing. I'm just going to extend it a little bit so that we can draw the bearing exactly as it should be. So I'm going to use a red mark for this. Okay, what happened is that it's going to be south 42 degree is, so for example, let's say if I were to sketch something like this, so this is the direction, so this is going to be my 42 degree, so it's going to move from south to east, and the angle is going to be 42 degree. And what is the distance from A until C? So we have been given the information, so the fact that the fire station from A until C is going to be 1.5 miles. Okay, and what else do information that we have over here? So no more. So that is basically all that we have from the information given. And the question says find the distance from C to the fire. Okay, distance from C to the fire is going to be right here. So this is going to be the line that is going to be our distance from C to the fire. And then we're going to find the bearing of the fire from C. So of course, when we want to figure out bearing, so please draw a straight line so we can figure out about the direction. Okay, the straight line. So this is going to be our north. Okay, first of all, so based on the information that we had, I am going to find, So what is going to be the value of CF? Okay, we have figured out some angle just now from our calculation. So we know that it's going to be 55 degrees right here. So this is an equation of a straight line. So straight away we can know what is going to be the angle over there. So it's simply going to be 180 minus 35 minus 55 minus 42. And this is going to give us an angle of 48 degrees. Okay, and we already know that this is going to be our angle, so which is opposite to our length CF. And now we just need another, what do you call that, one angle in order to find what is going to be our length of EF. So what else do we know? Do we have information from A to F just now? Yeah, we have information from A to F. So we know that A to F is going to be 0.86 miles. So here this is going to be 0.86. So that is the information that we had. So basically from here, can we find the length already? Okay, we have, yep. So basically now we already have enough information in order to find what is going to be CF. So because here, this is going to be our CF. So we already know two of the angles of the triangle, so which is the length, so which is going to be 0.86 and 0.86 and 1.5, and I can add up these two angles to find the angle that is opposite of the CF. And for this case, so we cannot use sine law, we have to use the cosine law. So by using the cosine law, so CF square is going to equal 0.86 square plus the other side is going to be 1.5 square, and that is going to be minus 2 multiplied by 0.86 multiplied by 1.5 and multiplied by cos of the sum of the angle, so which is 55 plus 48, and I'll get a value of 103 degrees. And of course I have to square root this value in order to get CF, but let me do the calculation first. 0.86 square plus 1.5 square, so minus 2 multiplied by 0.86 multiplied by 1.5, so multiplied by cos of 0.13. So that is going to give us a value of 3.5699. I'm going to square root that right away. So square root of the answer is going to give us a value of, if I get it in two decimal places, it's going to be 1.89. And of course, the unit is going to be in terms of miles. So now we already know, so that the distance from C to F, that is going to be 1.89 miles. So we have answered the first question, the distance from C to the fire. But we also have another problem that we need to solve, so which is finding the bearing of the fire from C. So here, so this is going to be our bearing of the fire from C. It's going to be right here. So this is our bearing of C to the fire. Okay, but the problem is that we have no idea what is going to be the angle right there. But the thing is that we can actually find the angle right here in red. So how do we find the angle at C? Okay, so now I'm going to use the sine rule. I think I can use sine rule for this. Is it possible to use sine rule? Let's see the information that we have. I need to find the angle at C. I know that this is going to be 0.86. Yeah, I already know that this is going to be 1.89 and this is going to be the angle, so yes. So I'm going to find what is going to be the angle at C. Okay, so sine of C over the length, so the length which is across C is going to be 0.86, is going to equal, so sine of 103 degree, so which is the angle right here, and the opposite of that is going to be our CF, which is 1.89. And now I'm going to find what is going to be the value of C. First, I'm going to find sine C, which is given by sine 103. So divide by 1.89 multiplied by 0.86. No, hold on. I forgot to put the bracket for the angle. Be careful with that. 1.89 multiplied by 0.86. So I got a value of 0.4433, so which I'm going to sine inverse. So when I sine inverse the answer, I will get a value of 26.32 degree. So that is going to be my angle C. But the thing is that we don't want the angle C, but our bearing should be here. It should be from the north. Okay, so how do we figure out what is going to be the angle right there? So let's say this angle over here, I'm going to call this as being gamma. So how do we find the value of gamma? So there is a parallel line going on here. So what do I mean by the parallel line? So if I were to take this two lines, so I'm referring to this line and this line, so they are actually parallel because both of them are actually heading north. Okay, and then I have a line so which goes across them, because this is my A and this is my C, and I'm actually referring to the line over here. So this is the line that I'm referring that going across, which is this line right there. Okay, and what we know is that the angle over here, this is going to be 42 degrees, and according to the rule of parallel lines, when this is 42 degrees over here, this is also going to be 42 degrees. So what I know is that both of this angle, when I add them up together, so this is going to be 42 degrees. So therefore from there I can find the value of gamma. So gamma is going to equal 42 degrees minus the angle of C, which is 26.32 degrees. So 42 minus 26.32, so that is going to be 15.68 degrees. So that is going to be our value of gamma. But we don't simply want the angle by itself, so we wanted the bearing. So basically from C to the angle, it's moving like this. So this is our north and it's moving towards the west. So therefore our bearing is given by starting at north. So it's going to be 15.68 degrees and we are heading towards the west. Okay, so that is going to be our bearing. So I know that this is not very easy for you to digest. So this is a lot of things, but this is how application problem is like. So you have to try to get as much information that you have from the question and try to come up with the sketching that you can actually use to figure out what are we trying to do in the question. So I actually have prepared for you like a bunch of questions for you to try over here. So the first one, I gave you sort of like a sketching just for you to start to familiarize yourself with the topic. But for B and C, for question number 3 and number 4, so you're going to start sketching on your own based on the information given. So you have to get familiar with this type of question. Right, so give it a go and then I'll